All right, today we're going to talk about something called literal equations. Literal equations. Literal equations are equations made up of more than one variable. So you've been used to things like 3x is equal to 15, right? Where we're trying to figure out, okay, what do I plug in for x to make this true? That x has to be 5, right? In order for this to be true. Now, when we talk about literal equations, we're talking about basically um, an equation with more than one variable with the ability to solve for different variables. So I'll give you an example. All right, if I had u is equal to y divided by x times k. All right. And I said I wanted you to solve for the letter x. So I would put a comma and then I would put the letter x. So u is equal to y divided by xk. Now solve that for x. So what I'm going to do is right now, this equation is solved for the letter u. So I'm going to rearrange this equation so that I'm left with x is equal to something. And that way it is solved for x. That's the indicated variable I want to solve for. Okay, so let's start with our equation. U is equal to y divided by x k. All right, so I need to get x in the numerator instead of the denominator in order to solve for it. So I'm going to multiply both sides of this equation by the letter x. It's going to cancel here, and I'm left with x times u is equal to y divided by k. All right. Now, if I want to get x by itself here on the left, I'm going to divide both sides by u. U will cancel on the left, and I'm left with x is equal to y divided by ku. All right, that is my answer. Now, I can just as easily have the same equation. So here I'll have u is equal to y divided by xk. And I could say instead of x, I want to solve for the letter y. So in this case, in order to solve for the letter y, to get y by itself, I'm going to multiply both sides of the equation by xk. If I multiply xk here, and I'll multiply xk here. xk will cancel on the right side, and I'm left with y is equal to xku. And because of the um, not transitive, but I think it's the reflexive property. Either way, I can switch both sides of the equation. All right, so there you have it. Y is equal to x times k times u. Okay, these are called literal equations. All right, so let's do another one together. Let's do z is equal to x times m plus y. And I want to do this one for x. Okay. So in order to solve for x, the first thing I want to do is I want to put this y on this side. So I'm going to subtract the y from both sides. And that's going to leave me with z minus y is equal to x times m. These will cancel each other. All right, so I have z minus y is equal to x times m. Then what I'm going to do is I'm going to go ahead and divide both sides by the letter m. That will effectively cancel the m on the right side, and I'm left with z minus y divided by m is equal to x. And I can flip those around. X is equal to z minus y divided by m. Okay. Let's do the same equation, but this time I'm going to solve for the letter y. So z is equal to x times m plus y, and we're going to solve for y. Okay. I'm adding xm to y, so I'm going to subtract xm from both sides. I have z minus xm is equal to y. And then I can just switch the sides to make it look nicer. Y is equal to z minus xm. And I've solved that literal equation for y. Now let's solve it for the letter m. We'll redo it. Z is equal to x times m plus y. So here, if I want to get m by itself, I'm going to subtract y from both sides. I'll have z minus y is equal to x times m, and then these two cancel. Then I will divide both sides by x. And I will be left with m is equal to z minus y divided by x. And I can switch it again. M is equal to z minus y divided by x. So I can take the same equation. We initially started with z, this is the initial equation, is equal to xm plus y. Okay, so this is solved for z. This is solved for m. This is solved for y. This is solved for x. Right, and there's similarities about them. M and x look real similar. And that's because you're multiplying x and m, and then you're adding y to get z. And so when you subtract y from both sides, you're going to have z minus y in both of the equations for x and m. And then you're going to divide by m if you're solving for x, or in this case, x if you're solving for m. So you kind of see some relationships that emerge there. All right, we had a couple of people join, so let me update the all right. We do another example for literal equations. So let's do A minus C is equal to D plus R. And we want to do this one for A. Okay. Okay. So if I'm going to solve this one for A, then I have A over here. I'm subtracting C, and then that's equal to D plus R. I'm going to add C to both sides of my equation. That'll get a by itself. So I'm left with a is equal to d plus r plus c. And what you'll find is solving for the other three are going to be pretty similar. Let's go ahead and do that. Let's solve for d. So a minus c is equal to d plus r. And we're going to solve this one for d. Same exact equation. We're just solving for a different variable. Okay, so I have d over here. So to get d by itself, I'm going to subtract r from both sides. And I'm going to get a minus c minus r is equal to d. Those r's will go away. And just so that it reads according to proper nomenclature, I'm going to switch the left and the right. D is equal to a minus c minus r. All right, now we're going to do the same thing, but this time we're going to solve for r. So a minus c is equal to d plus r. And let's do this for r. All right, so since r is over here, I want to get it by itself. I'm adding d, so let's subtract d from both sides. We'll have a minus c minus d is equal to r. And I can rewrite that as r is equal to a minus c minus d. All right. And the last one, I'm going to solve for c. So a minus c is equal to d plus r. And I want to do this for c. So c is over here. So to get rid of the a, I'm going to subtract a from both sides. So I'm left with negative c is equal to d plus r minus a. Now I have c by itself, but I actually have the opposite of c by itself, and I just want c. So I'm going to multiply both sides of this equation by -1. Okay. -1 times negative c gives me positive c. -1 times d gives me negative d. -1 times r gives me negative r. And -1 times negative a gives me positive a. And there you go. All right. Let's look at yeah. All right, let's do one like this. We have z is equal to x times m plus p all divided by x n. Okay, and we're going to solve this one for x. Now notice that we have x on the top and bottom. So this might be a little interesting. All right. Well, I can't subtract p from both sides. The reason I can't, and some students kind of start by doing that, is because if I have the fraction a plus b over c, remember that's a over c plus b over c. Okay, meaning that this is xm over xn plus p, over xn. So I could do that if I wanted to, and cancel the x's here and be left with one x. You can do it that way. But I did this to kind of show you that you can't just subtract p. Okay, so what I'll do is I might work that out a little bit. I'll work that out again, kind of doing that. So let me rewrite this and show you kind of the typical way to solve this. So one of the first things to do is always look to see, can you get rid of your fraction, right? If I multiply both sides of the equation by xn, then that will cancel here. Xn will multiply here. So x times n times z is equal to xm plus p. Okay. So now that I've done this, I've got x on both sides of my equation. So what I want to do is I want to get all of the terms, okay, terms are things we add or subtract. I want to get all of the terms that have x in them on the same side. So I'm going to bring this xm over here because anything that does not have anything that does not have x, I want on the other side. Okay, so this p does not have x. It's going to stay over here. I'm going to bring this xm to this side. So I will subtract xm from both sides. Okay? So you have x n z minus xm is equal to p. Now, the reason that I did that is now x is a factor in each one of these terms, meaning that I can pull out the common factor, right? I don't have any other factor. This term does not have an n, this term does not have a z, and this term does not have an m, but they both have an x. So I can factor out the x, and then what I'm left with is the quantity nz minus m. X times the quantity nz minus m. Then what I can do is I can divide both sides by the quantity nz minus m. And on this side, nz minus m. So this quantity and this quantity cancel, and I'm left with x is equal to p divided by the quantity nz minus m. And that is solving for x. All right, so let me show you kind of what happens over here. Here, x and x cancel, okay? And I'm left with z is equal to m divided by n plus p divided by xn. Okay, so now I've got x here in the denominator, and I've got another term here without x. I'm going to move that to this side. So I'm going to subtract m over n from both sides. And I'm going to get z minus m over n is equal to, these two are going to cancel, p divided by x sub n. All right. So now what I'm going to have to do is I'm going to have to get x to the numerator. So to do that, I'm going to multiply both sides of my equation by xn. And when I multiply both sides of my equation by xn, I will effectively get that x out of the denominator. So I'm left with just a p on this side. And over here, xn times z becomes xnz, and xn times negative m over n becomes negative xnm over n. And what we see here is that this n and this n will cancel. And so I'm left with xnz minus xm is equal to p. And you'll notice that this is exactly the same thing that I have here. And so effectively, we would do the same thing. We would factor out the x, just like we did here, and then divide both sides by nz minus m. It would cancel on the left side. X is equal to p over nz minus m. So you can still work it out that way. As long as you do legal math, you will always arrive at the right answer, right? There is no set way that you have to do these. Okay. So we're going to get into during this week, we're going to get into some word problems. So I want to talk about rates of change. What are rates of change? Okay. A very common one that anytime that you're in a car that you see is the speedometer. Okay. So if you're traveling down the highway, let's say, and let's say that you're going 70 miles per hour. Okay. That means for every hour that you travel, you're going to cover 70 miles. That is a rate of change. Rates of change always seem to have this word per. Okay. So in this case, 70 miles per hour, you can think of if you ever look at a toilet, they'll have what's called a GPF, which is gallons per flush. Sometimes it's in liters, an LPF, and that's liters per flush. And this is a certain amount of gallons for every flush. You're going to drop out there's a certain amount of gallons of water that's going to go through, or a certain amount of liters of water that's going to go through. Okay. You could have, let's see, what other rates of change? Well, the speed of light. The speed of light is measured in it's 3.0 times 10 to the 8th, and it's meters per second. Okay. For every second, light travels at 3.0 times 10 to the 8th meters. Okay, that's another rate of change. So this is what we mean by rate of change. A lot of times the bottom is time. Okay, obviously with this, the bottom is flush. It doesn't have to be time, but a lot of the rates of change that you're going to interact with in your life are going to be rates according to time. All right. So what we'd like to do is kind of look at the relationship between speed, distance, and time. Okay. Speed, distance, and time. So let's go ahead and say that you're traveling at 70 miles per hour. Okay. And you travel for 3 hours. Well, what's my distance? That's 210 miles. And how did I figure that out? Well, if I'm traveling at a consistent rate of 70 miles per hour and I travel for 3 hours, that means in the first hour I cover 70. In the second hour, I cover 70. So in total, I've covered 140. Then in the third hour, I cover another 70. So 140 plus 70 is 210 miles. But we can go the reverse. We can say, okay, someone traveled a total of 350 miles. And it took them 5 hours. Well, what was their speed? Well, the way that I would figure that out is I would say, okay, speed in this case is going to be miles per hour. So I know that I covered 350 miles per 5 hours. So if I do 350 divided by 5, I'm going to get 70 or 70 miles per every hour. So there's a relationship here that exists. If you are, for example, going 70 miles an hour, and you cover 280 miles, how many hours? You could figure that out too. You know that for every hour I'm traveling 70. So if I add 70 to itself 4 times, I get 280. So this is 4 hours. So there's a relationship here. And the relationship is distance. The distance someone travels is equal to the rate times time. Okay. Or what I often call the dirt equation. Okay. Dirt, even though it's an equal sign and not an I, it's close enough. Looks like the word dirt, right? Distance is equal to rate times time. And if I know two of these, whether I know distance and time, I can solve for rate. Or if I know rate and time, I can solve for distance. Or if I know distance and rate, I can solve for time. How would I do that? Well, this is a literal equation. So if I know rate and time, I could easily solve for distance. But if I wanted to solve for time, then I would take the equation that I know and I would say, hey, let's go ahead and solve that for time, t. So to do that, I would divide both sides by rate. And I would have distance divided by rate is equal to time. And I can do the same thing for rate. Start with my original equation. Distance is equal to rate times time. And I'm going to solve this for rate. In order to do that, I would divide both sides by time. And I have distance divided by time is equal to rate. So regardless in a word problem, for example, of what I'm given, I can manipulate the equation using what I know from literal equations to create an equation where I can go in there and solve for the unknown variable. So let's do one like that. So I'm going to kind of draw a picture here. So we're going to say that a plane leaves Singapore. Okay. And it flies at an average speed of 170 miles per hour. Okay. If the plane flies for 8 hours, how far did it fly? All right, that's the question that we are going to answer. A plane leaves Singapore going 170 miles per hour. And if the plane flies for 8 hours, how far did it fly? So we're going to use the dirt equation. Distance is equal to rate times time. Okay. Now we actually are, in this case, solving for distance. That's the question, how far? The question, how far, is asking about distance. Okay, if they asked how fast, they would be looking at rate or speed. If they asked how long, they would be looking at time. Okay, but in this case, we're asking how far. So we're going to look at distance. Okay, so the distance is equal to the rate, which is my speed, 170 miles per 1 hour, times my time, which is 8 hours. All right. So I do 170 times 8. Work that out over here. 1,360 miles. Now, for those of you in like a physical science class or really any physics type class, you'll talk about units. Okay. So this unit here is miles. This unit here is hour. This unit here is hour. Okay. Obviously, this is plural, 1 hour versus 8 hours, but we're talking about the exact same unit, meaning a number of hours. So if I have a unit in the numerator and the same unit in the denominator, they can cancel. The units will cancel. So the units that I'm left with are miles. That's why over here, the only thing that's left is miles, not miles per hour. Okay, the hours actually cancel themselves out. So this plane, when it leaves Singapore, travels 1,360 miles. Okay. All right. So let's do a similar. Plane leaves from the same airport, but it's going to go a different direction from Singapore. All right. This time, the jet going the opposite direction has a different speed. It's going 200 miles per hour. Okay. It also flies for 8 hours. 8 hour flight. How far did the plane go? How far did the plane go? All right, so it's the same equation, even though we're going in a different direction. Okay, we're just looking at distance, how far, and that's an absolute value. So if this is Singapore, if you go this way or this way, right? And let's say that, this is a negative number and this is a positive number. The absolute value is the question that we're asking. How far are we from the origin? So if this is at -5 and this is at +5, the absolute value of each is 5. So I don't necessarily put this in absolute value form, but you'll notice that I don't have a negative in front of the distance, signifying it's going the opposite way from the other plane. If I'm relating the two together, right, that's where it will become necessary to add a direction. But right now, we're simply asking how far did it travel going at that speed? So the distance is the rate of change, 200 miles for every hour, times this plane flies for 8 hours. Okay. So this plane goes 1,600 miles. That's 200 times 8. And again, the units of hours cancel each other, and the only units left are miles. So our answer will have miles, 1,600 miles. All right, so I'm going to do the same. We're going to kind of go a little bit more complex here. I'm going to do the same kind of scenario, except I'm going to change one little thing and ask a different question. So the first plane is going to leave Singapore, just like we did in our first problem, traveling at 170 miles per hour. And it's going to travel for 8 hours. Okay. The other plane is going to leave sometime later. And it's traveling at 200 miles per hour. Okay. You know that this plane is traveling for 8 hours, but what you don't know is you don't know how long this plane has been traveling because they do not take off at the same time. The first plane is going to take off, then some time later, the second plane is going to take off, and it's going to go the opposite direction. Okay. All right. After 8 hours, the two planes are 2,960 miles apart. This is after 8 hours. 8 hours from when? 8 hours from the time that the first jet took off. Okay. So this jet takes off sometime later, could be 5 minutes, could be 3 hours. We don't know. This jet takes off. But 8 hours after this jet takes off, these two jets are 2,960 miles apart. Okay. All right. What we want to figure out is how long, okay, how long was the second plane in the air? Or how long was it traveling? Okay. All right. So we're going to have to do some investigative work here. We know that the 8-hour flight from Singapore for this guy going 170 miles an hour, we know that in 8 hours he flies 1,360 miles. So we know that this distance here that he flies in 8 hours is 1,360 miles. So I can solve for how far this other plane has traveled. Because if they are 2,960 miles apart at 8 hours from when the first plane left, we know how far the first plane left. We can calculate how far the second plane went. So we would do 2,960 miles minus how far the first plane went, 1,360 miles. And what does that equal? Well, if I work that out over here, 200 or 2,960 miles minus 1,360 miles. This guy traveled 1,600 miles. Now, you'll notice that we already worked this out. This guy going the other direction flew for 8 hours and got 1,600 miles. So what that tells us is that they took off at the same time. Because in order for him to cover 1,600 miles, he would also have to have taken off right at the same time that the first one did. So what was the time later? It was 0 hours later. Kind of a weird problem, but I think it kind of communicates the idea. All right. Let's do a train problem. A train leaves a train station. Okay. It's going to leave Grand Central. It's going to hit a stop and then it's going to come back. Okay. So it's an out and back. It takes 1 hour longer to get there than it does to get back. The average speed, or the speed going, was 52 miles per hour. The speed on the way back was 65 miles per hour. So how many miles does the whole trip take? how many miles, I'm sorry, how long does the whole trip take? Not how many miles. How long does the trip take? We actually don't know how far. We're going to answer this question. Okay. So I'm going to break this up. It's an out and back. So there's a certain distance here that it takes to go out. We're going to call that distance. Distance number 1. Okay. The way back, we're going to call that distance number 2. Now, since it's out and back, we can say that distance 1 is the same as distance 2. Okay, they're the same. It's out and back. So distance 1 is equal to, and this is coming from my dirt equation, the distance is equal to rate times time. So my rate going out is 52 miles per hour times time. But I don't know how long. This is what I know. It's 1 hour longer to get there than it is to get back. Okay. So we're going to call this time just T. Okay. And what I'm going to say, since it takes 1 hour longer, there's actually 2 ways to set this up. So let me talk about the next one. You can do it 2 different ways. The way back is 65 miles per hour times time. Now, these times are not the same. Okay. It takes 1 hour longer to get there than it does to get back. So if this is the time it takes to get back, I can add 1 to this time. Okay. So let's just say it takes 12 hours to get back. If it took 1 more hour to get there, you could see why I put the plus 1. This would be 12 plus 1, or 13. Okay. So I have 52 miles per hour times time plus 1. And the second distance, 65 miles per hour times time. All right. We know that the 2 distances are the same. So we can use the transitive property here. If D1 and D2 are equal to each other, then this side of the equation is equal to this side of this equation. So we can say that 52 miles per hour times T plus 1 is equal to 65 miles per hour times T. Kind of crunch there. So I'll read it out loud. This right side of the equation is 65 miles per hour times T. Okay, so I'm going to take this 52 and I'm going to multiply it in. So that's 52. And I'm just going to write MPH for miles per hour times T. Remember, this is just a unit, so don't get that confused with T. And it's okay if you want to just do 52 times T and not have units on it. That might be a little bit simpler as you're kind of learning how to do this, okay? So we'll just do that. We'll leave the units off for now. So 52 times T gives us 52T. Then 52 times 1 gives us plus 52. Then here we have 65T. All right, I want to get my T's on the same side. So I'm going to subtract 52T from both sides. Since this already has a number here without T on the left. So that's 52 on the left. These cancel, equal to 65, take away 52. That gives me 13T. All right. Is that right? 665 minus 52. Yeah, 13. All right, then I can subtract or divide both sides by 13. And what does t equal to? 52 divided by 13 is 4. Good. So t is 4. Now, what is t? This is where it's very important to remember what your t represents. T represents the amount of time it takes to get back. That's what t is. T is 4 hours. Now, the question is, how long does the trip take? So I have to make sure that I add going out. So going out would be t plus 1. So that's 5 hours. 5 hours out, 4 hours back, 9 hours total. All right.